All right, guys, in this video, I'm going to answer this problem right here. This is question number 4 on page 135. So it reads that the price P in dollars and the quantity X sold of a certain product obey the demand equation P equals minus 1 over 3X plus 100 for X between 0 and 300. And then you're asked a series of questions. First, to express the revenue R as a function of X. B, what is the revenue if 100 units are sold? C, graph the revenue function using a graphing utility. D, what quantity of X maximizes revenue? What is the maximum revenue? And we're going to use our graphing utility, our graphing calculator to answer that question. And finally, what price should the company charge to maximize this revenue? All right, so the revenue, I'm just going to move this out of the way. And so the revenue, or, is a product of the number of units sold, that's X, times P. That's the price. So it's the price per unit. So it's the price per unit times the number of units sold. That's our revenue. We are told that the price, P, is equal to minus 1 over 3X plus 100. Given that in the problem, for X between 0 and 300. So we are asked then to express our revenue as a function of X only. So here we have our revenue as a function of X and P, and so we want our revenue as a function of X only. So OR then is equal to X times, and instead of P, I'm going to put in my price equation right here. So that is minus 1 over 3X plus 100. And that's essentially the first part of the question. You could distribute out my X here if I want. So I would have then OR is equal to X times minus 1 over 3X is minus 1 over 3X squared plus 100X. And that is OR as a function of X. So that's the first part of my question done. Second part asks, what is the revenue if 100 units are sold? So this is OR of X, and we are asked for, well, the revenue if X is equal to 100. In other words, we are asked for OR of 100. OR of 100. All right, well, that will be equal to minus 1 over 3 times 100 squared, X 100, plus 100X is 100 times 100. All right, so I've replaced my X in this equation here with 100. And now I just have to figure this out. I have OR times 100 is equal to 100 squared is 10,000. So I have minus 10,000 over 3 plus 100 times 100 is 100 squared, that's 10,000. That is 10,000. And so I have minus 10,000 over 3 plus 10,000. That is, work it out, equal to 20,000 over 3. And that is approximately equal to $666.67. We're talking about dollars and cents here. This is revenue. And so to the nearest cent, that is 67 cents. All right, so that's the second part of the problem done. That is the revenue for 100 units. Now we're asked to graph the revenue function, graph this function right here, graph this function right here, using a graphing utility. All right, so here's my graphing calculator, and I'm going to graph my revenue function. So I want minus X squared over 3 plus 100X. All right, so I want negative X squared all over 3. All right, so I have minus X squared over 3 plus 100 times X. I can graph that. And there's my graph. All right, I've actually adjusted the window ahead of time. Let me just give you an idea of my window settings. So my X minimum, I put -10. On my X maximum, I put 310. All right, so on the X graph, on the X-axis, excuse me, I'm going from -10 to 310. I knew that my X values were between 0 and 300, so I went a little either side of 0 and a little to the left of 0 and a little to the right of 300. On my y-axis, well, I know that R of 100 is 6,666.67, and so what I did was on my y-axis, my y minimum, I put in -10, but at my y maximum, I put in 10,000, because I know that like I say, for R of 100, I've got a little less than 7,000 here, so I just estimated up to about 10,000. I can always, of course, adjust my window, but I'm happy enough that 10,000 does that job for me, and my graph looks nice, and it's nicely centered on my graphing utility. So that's the part C of the problem done. We have graphed it. Part D, where I'm also going to use my graphing utility, asks us what quantity of X maximizes revenue. And what is that maximum revenue? In other words, what we want to find is the maximum value of our graph, or the highest point of our graph is what we're looking for here. The easiest way to do that is just use my graphing utility. So if I go to second function, calculate, and I want the maximum, that's number 4 right there. And you can see that I'm asked for the left bound, so I'm going to go a little to the left, hit enter. My right bound, I'm going to go a little to the right, enter. Now I guess, and it gives me that the maximum X is at 150. So I'll put X max, just put this over here, my X max, I'll call it, maximum revenue is at 150, and my R max, that is my maximum revenue, is my Y value. So my Y value is 7,500, and so my R max is 7,500. All right, so my X max is 150 and my R max is 7,500. That is that maximum point of my graph right there. All right, so that is part D answered. I have found the value of X that maximizes the revenue, and I have found that maximum revenue. The final part of the question asks us, what price should the company charge to maximize revenue? Well, in order to find that out, I'm going to go back here to this equation. This is my price equation. And I know that my Pmax, my maximum, the price that maximizes revenue, will occur at my value of X that maximizes revenue. And so what I'm going to do is I'm going to substitute into this equation here my X max value. So that is my P maximum, the price that maximizes revenue, P max, is going to be equal to -1/3 times X max. Well, X max is 150. My calculator out of the way. Plus 100. All right, so working this out then, 150 divided by -3 is going to be -50 plus 100, and that is going to give me -50 plus 100 is 50. So $50, that is the price, according to this equation right here, that is the price that will maximize revenue for me. And that is part A, B, C, D, and E. That is the entire question answered, and that's how we go about solving problems like this. So we start with our revenue equation right here, and then we substitute in, we're given a price equation, and we substitute in our price equation into our revenue equation, and therefore we're able to get revenue as a function of number of units sold, X. All right, thank you.